All right, let's go ahead and get started. Welcome everyone this morning. Thank you for showing up early on the morning after the party. Appreciate that. You must all love Service Manager and Azure a lot to be here at 9 a.m. on the morning after the party, so well done. We'll try to keep it entertaining here, as entertaining as Azure migration can be anyway. But so I'm Travis Wright. I'm the Director of Product Management at Cireson. Formerly with Microsoft for 11 years as Principal PM on the System Center team. And today this session is really just all about talking about our recent experience of migrating our Service Manager instance plus Cireson sitting on top of it to Azure, and talking about sort of some of the lessons that we learned from that experience, and hopefully helping you avoid any of the same problems that we had that kept us up till 4 a.m. in the morning 3 nights in a row. So. It was a very painful weekend. Friday, Saturday, and Sunday night, we were up. We worked on it for probably 12 hours each day till like 4 a.m. in the morning each day. It was quite an effort to do it. But most of the things that went wrong, we learned from, and I'm here to share those things with you today. And hopefully your Azure migration, if you decide to do that, will be much easier. Is anybody operating Service Manager in Azure today? Yep. Got a few? Okay, cool. How's that been going for you? Is it good? Yeah, okay. All right, so we'll just start out and just talk about a typical Service Manager deployment topology. And then we'll go through the step-by-step migration that we did to Azure and talk about some of the best practices and things that we had challenges with and what we did to work around those. And then I'll go through kind of an analysis of why we chose to move our infrastructure to Azure. So a typical Service Manager deployment topology, if you want to keep it pretty simple, is you have a domain controller because Service Manager requires authentication against an Active Directory domain. You have one or more management servers, typically more than one. There'd be 2 to 3. And then typically a SQL cluster where you store the databases for Service Manager. And in some cases, if you have the data warehouse, there may be more servers than this, like a data warehouse management server, potentially another SQL cluster to host the data warehouse databases. But for simplicity for today, we'll not talk about moving the data warehouse, and we'll just focus on moving Service Manager itself. So for the conversation today, this will be a real-world example. This will be based on our experience of moving our Service Manager and our Cireson self-service portal that we use to service our customers from a hosted environment where we were working with a hosting provider to Azure. And this is actually our production environment that we were migrating across, right? So let's go now through each of the steps that was involved in doing that migration. The first step when you move anything to Azure is you need a virtual network in order to be able to connect all of the virtual machines on that network together. So creating a virtual network is quite easy. You just log in and get your subscription. So to start with, actually let me kind of back up here a little bit with the subscription part. You kind of have two choices, right? You can go and create a subscription and just give Microsoft your credit card, or you can go and talk to a large area reseller and you can get a subscription set up that way. And if you do it that way, there's discounts that are available if you commit to purchasing a certain amount of Azure in a year and you pay that amount up front. And so what we did is we went and we talked to the LAR, and we negotiated an agreement with Microsoft, and that got us a discount, and we agreed to pay all of the Azure commitment up front. And then if we spend more beyond that, that's fine. We just pay as we go beyond that point. But because that process takes a little while, we started with a subscription that's just based on our credit card. And once this subscription is finalized next week, then we'll move the subscription over to be on top of that agreement, basically. So you kind of have two ways you can go, but ultimately, if you're going to spend a lot of money on Azure, then you want to be doing it through a large area reseller so you can get those discounts. So once we had the subscription set up, then the first step was to create a virtual network. So to do that, we just went to the new menu, chose Network Services, Virtual Network, and in our case, we chose Custom Create, but you can also choose Quick Create. This is the experience to go through when you're doing Custom Create. You give your virtual network a name, and you choose a location. So one thing you'll want to be aware of when you're choosing a location for any of these types of things is that some locations cost less than others. So you'll want to talk to your large area reseller and get the price lists from them, or at least have them show you the price list. And you'll see that depending upon the region, the cost will be different. So there's two data centers here in Europe. You might want to just take a look at the cost differences between those two when choosing which data center you want to use. So once you choose the region, then you specify the DNS server name. Now in our case, we had already provisioned a VM that we knew would be the DNS server, and so we just grabbed the IP address of that server and added that in here. So we just typed in the server name, the VM name, and the IP address there. And then in our case, we needed to create a site-to-site VPN, okay, because what we were doing was we were migrating from our hosted site to Azure. So we needed to be able to create a site-to-site or point-to-site VPN so that we could bring some of the data across a VPN connection as we were migrating. I'll show you exactly what the scenario was, where that was required. So we also configured a point-to-site VPN. And once you do that, then you can see kind of down here below that that's what it looks like when you have a healthy connection between the two. Then we create a virtual network address space. So here you choose the IP address and the CIDR addresses that you want to have. And so in this case, we set up an address space that you can see up here. And then you just point to whichever DNS server you want to use. Okay, then once you've done that, and you've created your virtual network and your point-to-site VPN, then you need to create a certificate. And the certificate is used to encrypt the communication that happens on the VPN network. And you can use the makecert utility. You can just do a search for that on the web and find the makecert utility and create a root certificate as part of that. And then once you've got that certificate created, then you drill into the virtual network. You go to the certificates tab, and there's an upload button there. You click upload, browse to the certificate file, and upload that certificate. And once you do that, you then have a point-to-site VPN set up. So what that looks like this. If you don't have any clients connected, then in the Azure UI, it will look like this. You'll see kind of a disconnect because there's no clients connected. When you do have a client connected, it'll look like this. It'll show that you have a gateway and some number of clients connected to your VPN. So once you have and by the way, I've kind of masked some things in here as we go. So that's why I'm using like screenshots instead of like a live demos, because we obviously don't want to show all of our information. But down here, once you've created that VPN and you've got your certificate uploaded, and you have to have your certificate uploaded first before this will show up. Once you have your certificate uploaded, then you can download a 64-bit client VPN package, or 32-bit if you need it. And then you can take that VPN installer, and you can go to whatever computers you want to set up your point-to-site VPN connection on, and you just install that VPN client. And then you take the certificate that you generated and uploaded into Azure, and you also import that into the local computer personal certificates. So you go into MMC, you add the certificate snap-in for the local computer, and you add the certificate into the local computer's personal certificates. And then you can just go to network connections, and you'll see your VPN client in there, and you can just choose to connect with that. That'll bring up this UI. And you just click connect, and that'll create a VPN connection between that computer that you're on and the Azure virtual network that you've created. So at that point, that computer can communicate with any of the computers that are on that virtual network in Azure. All right, any questions on that? Okay, just feel free to jump in with questions. We'll probably have some extra time at the end, so we can ask questions along the way, or we can have questions at the end as well. So at this point, our network and architecture diagram looks like this. We've got a virtual network created in Azure. We've got the old domain controller sitting in our hosted infrastructure, and our old service manager management server sitting in our hosted infrastructure, and our old SQL server sitting in our hosted infrastructure. And then we've set up the certificates and the VPN clients on both the old domain controller and the old SCSM server. And we've connected the VPN client up to the virtual network in Azure. So at this point, as we start to create new virtual machines here in Azure, these virtual machines that are running in our hosted infrastructure will also be able to communicate with those machines in Azure. Okay, so the next step is to deploy a cloud service, and a cloud service is really just a container for virtual machines. And any virtual machine that's within that cloud service can communicate with any other virtual machine that's within that cloud service as well. So the first step here is just to go to the new menu, go to compute, go to cloud service, and this is very simple, so you can just choose the quick create option. You provide a name and a region. And again, just remember that whatever region you choose potentially costs more or less compared to other regions. So do your homework on that before you choose the region. Because once you create a cloud service in a given region, you can't move a cloud service from one region to another. And all of your virtual machines are inside of that cloud service. So if you ever need to move your virtual machines from one region to another, it's a pretty painful process because you basically have to take all of your VHDs that are behind those VMs and move them to storage and then create new VMs out of them in the new region. So it's a lot of work to have to move VMs from one region to another or a cloud service from one region to another. So you want to make sure you make that choice right to begin with. In our case, the US South Central region is the lowest cost region. And that is also the region that is kind of the best location for us because we have employees that are on the West Coast and on the East Coast, and some in the Central region. And we also have customers worldwide. So, choosing a region which is, in a good location relative to your users is important. In this case, it happened to be that the lowest cost data center is also in the best location for us. Okay, once we have a cloud service, then our next step was to move the domain controller to Azure. So in our environment, we have a domain controller which stores all of the user accounts for people that are accessing our customer support portal. So our customer support portal is the Cireson portal product that we put out there and interface with our customers. And every customer that we have, every user at that customer that's going to be using our portal, we provision a user account for them in our Active Directory, right? So when somebody logs into our portal, they're using forms-based authentication. And that forms-based authentication is authenticating with the Active Directory domain that we've set up for this customer support portal. So that Active Directory domain controller is really important because that contains all of the user accounts for all of our customers. So we didn't want to leave that behind in the old infrastructure, and we didn't want to have to recreate all the user accounts. So we want to move the domain controller from our hosted environment up to Azure. So we had two choices with that. One, we could back up the domain controller as a VHD and upload that VHD to Azure and then create a new VM from that VHD. Or we could set up a new domain controller in Azure and then have that be joined to the domain with the existing domain controller and then replicate all of the Active Directory information from the old domain controller to the new domain controller. So that was the approach that we chose to use, was to create a new domain controller in Azure, and over the point-to-site to VPN connection, do the replication, and that way we wouldn't have to do all the process of creating a VHD out of this VM and uploading that VHD and creating a new VM. So the other benefit of that was that this domain controller was a Windows Server 2008 R2 domain controller, and we wanted to move forward and use a Windows Server 2012 VM. So we had a newer VM up there. So we kind of needed to do that anyways, so we chose the replication approach. So the first step for us was to create a new virtual machine for the domain controller. And by default, kind of the standard operating system for a VM inside of Azure is Windows Server 2012 R2 Enterprise. And in this particular case, we chose an A2 standard VM, which is 2 cores and 3.5 gigabytes of RAM. And that costs $134 per month list price on the Azure site. So to create that, we just went to the new menu, compute, virtual machine, and quick create, and then we provided a name for this virtual machine. We chose the image that we wanted to create it from, in this case Windows Server 2012 R2 Enterprise, the size, which was A2, and then a initial user account and password that you can use to log into that machine once it's created, and then you can put it into a particular region. All right, then we promoted that virtual machine to be a domain controller. So first we installed the Active Directory Domain Services role, In our case, because we needed a DNS server, we also installed the DNS role. Then we joined the computer to the domain. And in order for that to happen, the VPN client of the old domain controller VM needed to be connected to our Azure virtual network over that VPN client. So that connection had to be live in order to do that, right? Because it needs to be able to join the domain that's hosted by the old domain controller. Then we promoted the VM to be a DC. We waited for replication, and again, that was happening over that VPN connection. And then in our case, we cut off the VPN client connection once the replication was completed to stop the replication from happening anymore, because that old domain controller was no longer useful anymore. We don't need it. So at this point in time, our architecture looks like this. We now have a new domain controller VM inside of Azure, and we've done the replication over the VPN client from the old DC to the new DC. So now the new DC has all of our user accounts, all the computer accounts, and it's all ready to go to be a new domain controller for this new virtual network inside of Azure. All right, any questions there? No? Okay. So the next step then was to migrate SQL. So to migrate SQL, again, we had a choice. We could either create a VHD from our old SQL VM and upload that to Azure and create a new VM from that, or we could back up the databases and move the databases from our old SQL server up to our new SQL server, and then just hook up everything to the new SQL server by changing the connection strings. So that was the approach that we took, was to do backups. So the first step was to create a new VM for SQL. So that was based on Windows Server 2012 R2 Enterprise. And we chose a D2 type VM in this case, which is 2 cores and 7 gigabytes of RAM, and installed SQL Server 2012 Standard in that environment. And the prices for those are $254 a month for the host operating system, and then for the SQL Server, it's $298 per month. And the reason we chose a D-series machine for this instead of an A-series is because the D-series computers are 60% faster in terms of their CPU, and they have SSD storage that's local to the computer. So that's really good for a SQL Server because obviously you want to have fast spindles behind your databases. And then we joined the SQL Server to the domain. We backed up the Service Manager and the Service Management DBs on the old SQL Server. We copied those database backups to the new SQL Server. So the database backups in this case were, maybe like 2 or 3 gigabytes or something like that. So it was really much smaller than trying to copy an entire VHD that's maybe 30 or 40 gigabytes from our old environment to the new environment. So that really saved us a lot of time because we didn't have to wait for the entire VHD to upload. Once we copied those databases up there, we then restored them. And then a couple things that got us was that by default, named pipes is not enabled on a SQL Server, and that's required for Active Directory connectors. So after we migrated everything over, everything was looking great, and my support team called me the day later, and they're like, our Active Directory connectors aren't working. I'm like, okay, well, I don't know why. So I went and looked at the event viewer and figured out that the reason Active Directory connectors weren't working was because named pipes was not enabled on SQL Server. So definitely watch out for that. And then another thing that got us was that when we deployed the new SQL Server, we used the Latin 1 SQL collation, and the old SQL Server had the SQL_Latin 1 collation. And so when we restored the new databases up in the new SQL Server, we had some issues with the collations. So as you move forward, make sure that you use the same SQL Server collation if you're going to create a new SQL Server and move the databases to it. And the reason for that is because the temp database in a SQL Server will always be the same collation as the SQL Server default collation. And in this case, we had a temp database that was one collation, and the Service Manager and Service Management DBs were another collation. And some of the operations that happen in both Service Manager and Service Management require comparing data between a temp table and a table in one of the databases. And when the collations are different, then it has an error when it tries to compare that data. Okay, so at this point, our architecture diagram looks like this now. We've added a new SQL Server VM to our virtual network. We've joined this SQL Server to the domain that is hosted by this domain controller. and we've backed up and restored the databases to the new SQL Server here. Okay, so next would be to migrate the Service Manager Management Server and the Cireson portal. So in this case, we created new VMs for Service Manager and the client Cireson portal. And we chose, again, Windows Server 2012 R2 Enterprise as the operating system. And in this case, we chose A3 as the VM pricing tier. And that's because we needed more processing power in order to drive both the Service Manager Management Server and the Cireson portal. So in this case, we got 4 cores and 7 gigabytes of RAM. And we then installed the prerequisite software in the VMs for the Service Manager Management Server and the Cireson portal. That's a very easy process to do in both cases. The installers for both of those products will install the prerequisite software for you. We then joined the Service Manager VMs to the domain, and we made sure that the old Service Manager VPN connection is established, okay? Because what we needed to do was then change the database connection string in the old Service Manager Management Server, which is in this registry key here, to point to the new SQL Server. So once we did that, we had the old Service Manager Management Server running on our hosted infrastructure, was able to communicate over the VPN client connection to the new SQL Server. And so at that point, that Service Manager Management Server was operational. I could open up the Service Manager console on it and it would work fine because it was talking to the old database, which was now restored on the new SQL Server. And that's important because when you install a new management server into a Service Manager management group, that new management server will connect to the Service Manager database and find out what one of the other Service Manager management servers is, and then it will communicate directly to that management server and get the encryption key from that existing management server. And that's the only way that you can do it. So that original management server we had, the old one, that server had to be live and connected to the SQL database in order for us to get the encryption key from that old server and apply it to the new server. So that was another very tricky thing to realize that that's what was going on. So you have to have that old Service Manager management server up and running in order to be able to install additional management servers into the management group. Okay, then we just installed the new Service Manager management servers and pointing those to the new SQL. And then we installed new Cireson portal instances pointing to the new SQL and the new Service Manager that was installed, and the existing service management database as well, which contained all of our knowledge-based content and settings and other things that we needed to have in the service management database for the Cireson portal. So another tip here is just to install the Service Manager Management Server and the Cireson portal server together on the same server, and just create a farm of those, however many you need. In our case, we use 2, but I've seen customers use up to 4. So, all right, then a few other things that needed to happen. There are other miscellaneous files that Cireson and other third-party products put on a server. Okay, so for example, we'll use a simple example of like the Cireson auto close app. That's a workflow that runs behind the scenes that automatically closes work items after a configurable period of time. And there's a workflow DLL that has to be deployed into the Service Manager installation directory. So we had deployed the auto close app on the old Service Manager management server, and we needed to copy that DLL from the old Service Manager management server to both of the new Service Manager management servers. So what we actually did is we went and copied the entire installation directory of Service Manager on the old server, and we just copy and pasted it into both of the new Service Manager management servers, and just told it not to replace any existing files that were duplicates. So that way we copied all of the sort of non-standard files from the Service Manager installation directory to the new servers. And that picks up all the Cireson and other third-party DLLs. And you also want to make sure that you copy all of the DLLs and other files to both servers. So even though only one server at a time can be the workflow server, you never know. At some point in the future, you may want to fail over and have one of the other management servers be the workflow server. And you want to make sure that all the workflow DLLs that it needs are going to be there. because you'll forget about it 6 months from now. So you want to make sure that all those DLLs are there and they're always replicated and the same, so that if in the future you do need to fail over, the files will already be there. Okay, so once we had made this migration and had 2 new management servers now, we needed to, this was our old management server was our workflow server within this management group. So now we needed to promote one of the other workflows, one of the other management servers to be the workflow server. And so there's a procedure that's documented here at this URL on how to do that. You basically just run a query inside of the service manager database, and that'll make one of the other management servers be the workflow server. Okay, then we had to make sure that we had connectivity to all of the connector data sources, so things like Active Directory and Exchange in our case, but in your case you may have connectors to Configuration Manager, Operations Manager, Orchestrator, SMA, so you need to make sure that you still have the connectivity required to all those different resources. So you might need to open firewall ports, you might need to make sure that authentication is working across domains, but it's something to take into consideration. And I would definitely think through this part of it before you move to Azure. Make sure that once you move to Azure, the management server that will be running in Azure will have all the necessary connectivity to all of the data sources for your connectors. Okay, now in our case, we were using a local SMTP server that was installed on our old Service Manager management server to send all outbound notifications. So we installed a new SMTP server role on each of our new SM management servers and change the configuration for outbound email in Service Manager to use those new SMTP servers. Okay, then we configured the Cireson portal website as usual. We added in the usual site bindings and added our certificate for SSL. In this case, the certificate didn't need to change because we were still using the same domain. It was still support.cireson.com. So we were able to use our old certificate even though we were now operating it inside of Azure. And once that was all done, then we uninstalled the old Service Manager. So at this point, our environment looks like this. We have a new domain controller. We have 2 new Service Manager management servers, one of which was promoted to be the workflow server. And both of these have the Cireson portal installed on them, and both of them have an SMTP server installed on them. And we still have the SQL server. And all of these are joined together in the same domain. And at this point, we no longer need any of the old infrastructure. So we disconnected the VPN clients and shut off all of those old virtual machines. And now we're running completely inside of Azure. Okay, but at this point, nobody could really get to support.cireson.com, so there's some additional work that we had to do in order to enable that access. Okay, anybody have any questions so far? No? Yes?
Service manager is quite like operation manager, so operation manager has a lot more knowledge.
Yep.
So if one gets stuck on something, looking for operation manager knowledge, say like the collation, all that is really good documented for operation manager.
Yeah. Yeah. Yeah, absolutely. Okay. Any other questions or comments? Okay.
Just one maybe.
Yeah.
On which partition did you install the SQL database? Because you were saying that you chose the D-series VMs for the SSDs.
Yes. Yeah.
On that temporary partition, I think.
Yeah, so there's a temporary partition that gets added to every VM. And in our case, we were using a D2, and so there's actually a set of data drives, and we installed all the databases to the data drives, and we installed SQL on the operating system drive. Okay, so the nice thing about a D-series virtual machine is that it gives you 4 SSD drives just for data, which is great. I mean, it's a lot of spindles to have to spread out your databases on. All right, any other questions? No? Okay. So then, as far as load balancing goes, Azure provides a kind of like a universal load balancer for Azure, and you can configure endpoints inside of your virtual machines that the Azure load balancer then uses to load balance incoming connections across. So to configure load balancing, you want to create a an endpoint. So when you create an endpoint, you go to the virtual machine and you create an endpoint, and you give you go to the inside of the virtual machine, there's an endpoints tab, you can click new, and there to start with you would go, in our case, to the first server, and you would create an endpoint, and you would specify the protocol that you're creating an endpoint for. In this case, I'm doing the HTTPS one, and that's a TCP connection on port 443. And I'm going to create a load balance set. So I check this box, and on the next screen, it prompts me to provide a name for this load balance set. So I do that, and then there's a probe that can be used to probe that and make sure that it's available. And I just chose the default settings on that. And so then you would repeat this process for your HTTP on 80, HTTPS on 443, and on port 5724, this is the connection to connect to the Service Manager Data Access Service. So we created a load balance set for each of those, 3 different ports. And then once you do that, then you go to the other servers that are going to be in your load balanced group, and you create a new endpoint, but in this case, you add an endpoint to an existing load balance set. So here I'm choosing the SCSM load balance set, which is for port 5724. And then I just give it a name and save it, basically. So at that point, I now have a load balance set and an endpoint on each server for each of those load balance sets. And I have a load balance set for HTTP on 80, HTTPS on 443, and for the Service Manager Management Server Data Access Service on 5724. So that way, you set up these load balance sets for each of those different ports, and the Azure Load Balancer will balance the incoming load coming into that environment. Now, what you're doing is you're creating a load balance set across these machines within that cloud service. So in our case, the cloud service was called Cireson Portal1.cloudapp.net. Okay? And so this is now the internet-facing domain address that is available, and this has an IP address associated to it that Azure manages. And whenever somebody hits this DNS address right here, it'll resolve to the IP address for our cloud service, and whatever port is being connected to, the Azure Load Balancer will take care of directing that connection to one server or the other. Okay, then we needed to create a CNAME in DNS for our domain. So our domain that we have people access our support portal through is support.cireson.com. And we manage our CNAMEs in Office 365, actually. So I logged into our Office 365 admin portal, went into our DNS configuration there, and I added a CNAME record for support.cireson.com, and pointed that to CiresonPortal1.cloudapp.net. And now if you go out on the internet and you ping support.cireson.com, you'll get this address 23.102.191.135. That is the IP address for our cloud service. And the 2 virtual machines for the Service Manager and Cireson Portal are behind that load balancer that's receiving connections for that particular cloud service. And also, if you ping CiresonPortal1.cloudapp.net, you get the same IP address, right? So this is just a CNAME record for this cloud service here that Microsoft is hosting for us. All right, so now, if we look at our architecture diagram, we have the same infrastructure we had before, but we now also have an Azure load balancer sitting in front of it that's load balancing connections coming in from the cloud on 80, 443, and 5724. All right, so any questions on that? That was probably one of the trickiest parts of this, was figuring out how to set up the Azure load balancing sets. Once it's not really obvious how to do this in the UI, but once you sort of figure out, okay, I'm going to create an Azure, I'm going to go into my virtual machine, I'm going to create an endpoint, and when I create this endpoint, I'm going to create a new load balance set, and then I'm going to add other virtual machines endpoints into that load balance set. That's kind of the way it works. So it's a little tedious, actually. If we had like 10 servers, it'd be really annoying to have to go to each one of those 10 servers and create those endpoints and add them to the load balance set manually. So I think as you scale out, you'd probably want to look into doing some PowerShell or something like that, but it's not too bad. All right, any questions on the load balancing part? No? Okay. All right, so what didn't work? There were a few things that I pointed out along the way that we sort of ran into as a problem as we went, but there were a few things that just didn't work. And so I just wanted to kind of point those things out here so that you don't waste time doing them like we did. So we aspired to use the latest and greatest technology, and so we wanted to at least try to deploy a SQL Server 2014 always-on availability group, and then deploy at least the Cireson Portal Service Management database into that SQL Server availability group, because as far as I know, Service Manager doesn't support being deployed into a 2014 availability group. So we wanted to at least put the Cireson portal in there. So we went to the new Azure portal, and the new Azure portal has this gallery, and there's a nice big red button right there that says SQL 2014 availability group. And in theory, you click that and you configure what you want, and you click go, and it should just create everything for you. And in our test subscription, it worked fine. And in that case, it was creating even a domain controller for us and everything. It was very slick. Like, it just creates a domain controller, it creates a virtual network for you, it lays out the availability group, and everything just works. It's great. But when we tried to do this within our production subscription and have it provision this new availability group within our current domain, that failed. And it would take maybe 2 hours before it would fail. And so you were sitting there waiting, like praying, please, please, please work, for like 2 hours, and then in the end it would fail for some reason. And so we finally gave up on that. But for whatever reason, that doesn't work. We're setting up our support agreement with Microsoft for Azure right now. And once we get that set up, then we'll use some support hours to figure out why that's not working. But that didn't work for us. We tried to install SQL 2014 first and use that as our database server. And we tried to install Service Manager on that, and that didn't work. And we couldn't figure out how to work around it, so we gave up on that too. And then, as I pointed out earlier, you have to have the collations be the same, not only between the old SQL Server and your new SQL Server, but also Service Manager and the Service Management database need to be in the same collation. So we ended up in a configuration where they had different collations, and that was a problem. So make sure that those have the same collation. And then we did try migrating some of our VMs from our old site to the new site, and that took forever. It took maybe 20 hours to copy VHDs from our old site to the new site. And it worked the first time when we were sort of just doing a trial run, but it didn't work the second time, and it just took a really long time, and oftentimes wouldn't work to upload the VHDs. The upload process would fail. So if you can, I would recommend deploying new VMs and moving the configuration or replicating it like we did, instead of trying to copy entire new VHDs up to the cloud. All right, so what's next for us? We're going to, so right now we just have a single SQL server. We want to have a highly available, always-on group so that we can deploy our support databases on one of the nodes in the availability group and deploy a new demo and kind of like a customer sandbox environment with the databases on another node within that availability group. So we're going to set up a availability group, load balance the databases across the nodes within the availability group. So that's another step for us. And then we'll also need to deploy the Service Manager management server VMs for that demo and customer sandbox environment. So we'll end up eventually with having 3 different Service Manager instances with their corresponding Cireson portals sitting on top of a single domain eventually. In the next probably month or so, we're going to finish this deployment. So we'll have 3 full deployments of Service Manager in there. And then we're also going to be using this environment to automatically provision development environments and test environments. And we've already started and are almost done with having a staging environment. So there's a whole server that's set up just like our production servers for support. has its own service manager instance, it's connected to the same Active Directory, we'll deploy all the same management packs to it and everything like that. So we have a staging server that we can deploy a new build to, test it there first before we actually push it into production. So all of that is sitting within this new Azure subscription now. We're going to install a second domain controller in this environment just for redundancy and performance. And we want to raise the domain functional level from 2008 R2 to 2012. So that was another reason why we kind of moved up to the 2012 R2 domain controller, was so we could upgrade the domain functional level as well. All right, so that completes the migration process that we went through until 4 a.m. in the night for 3 nights in a row, doing, part of it was like an experiment to see what we could do. And, we found the things that we could do, the things that broke, and so on. So any questions on how we perform that migration? Yep.
How was the licensing issues regarding Service Manager on-prem, Service Manager to Azure, SQL licensing, and so forth?
Yeah, okay. So as far as the Service Manager licensing goes, that is the same regardless of whether you're running in Azure or on-prem. You have to have a license for every managed OSE that Service Manager is managing. So I'm not sure how familiar you are with Service Manager licensing, but with Service Manager licensing, you pay for the things that you're managing, not for the server itself. So that's the same, regardless of where it's running. As far as the SQL licensing goes, when you get a SQL Server VM from Azure, there's a separate pricing for SQL Server VMs that is separate from the operating system VM license. So you pay a certain amount for the virtual machine itself, and then you pay a little bit more on top of that for the SQL Server. So if we go back here to right here, you can see that this is the list price, is $254 per month for the virtual machine itself, and then $298 per month for a D2 SQL Server on top of it. Okay.
But could you use your System Center SQL license and install SQL Server yourself and get rid of those extra $290 or do you have to commit to that SQL installation?
That's a good question. I don't know. I don't think that they really have a way in Azure pricing to be able to account for the fact that you have a SQL license from System Center. So, the way that I would probably do that is when you're talking to the LAR, is to negotiate that discount into the pricing that you get from Microsoft as part of the deal. It's a good question. Okay. So let's go on to the why Azure section. So why did we switch to Azure? Okay, so the biggest reason that I didn't want to move to Azure was because looking at the Azure costs, I thought that it was going to be much more expensive than what we were doing with our hosting service provider. We decided, regardless of whether it cost more or not, because we're a Microsoft partner, we wanted to be on Azure and have a reference architecture of how to deploy Service Manager in Azure. What I discovered in the end, though, was that Azure was actually less expensive for what we got than what we were getting with our hosting service provider. So the cost per month did actually go up. So I won't share any costs because I don't want to give away Microsoft's secret pricing strategy or anything, but the amount that we paid at the hoster was X, let's say, per month. And what we're now paying with Azure is about 30% more than we were paying with our hosting service provider. But we're getting a lot more than what we were getting with our hosting service provider because we now have 2 management servers, we have a better SQL server, we have a better Active Directory domain controller, and so on. So if you start to break it down by the cost per gigabyte per month of RAM, for example, before we had 14 gigabytes of RAM for a certain price, now we have 24 gigabytes of RAM, and that price per gigabyte per month is actually 30% less than what we were getting from our hosting service provider. The same with a cost per core per month. We had 5 cores before, we have 12 cores now, and we're paying 85% less per core per month with Azure. The Windows Server licensing on top of it is now included, whereas before with the hosting service provider, we would have to purchase a Windows Server license for each guest operating system that we had running at the hoster. So that's another big savings. I don't even know how much that costs, but it's a lot. And the same with SQL Server. So this price up here, this includes the cost of SQL Server. So even if you factor in the cost of SQL Server, this is still 30% less and 85% less. So the cost of SQL Server is actually included here. If we were to continue running this at the hosting site, we would have to pay for a SQL Server license here as well. All right, then the disk space, one of the main reasons we decided to move to Azure from our hosting service provider was because we were continuously having problems with our host operating system not having enough disk space for our virtual machines and all the snapshots that we were creating on it. And so with Azure, your disk storage is essentially unlimited, and you just kind of pay as you go, and you don't have to worry about that anymore. The disk speed, so now we're talking more about value, right? So the disk speed that we had on our hosting service provider was just standard hard drives. With Azure, all of our regular A series VMs are all regular hard drives. But now our SQL Server data drives are all SSD drives. So I'm getting better value by going with Azure in that sense. And similarly, with the hoster before, the host Hyper-V server had 4 drives that were configured in a RAID 1 configuration, and all of our virtual machines ran on there in just regular VHDs. Now with Azure, I have 4 data drives that are all SSDs just for my data on my SQL Server VM, right? So I get to spread out the I/O on much more spindles in Azure than I had with my hosting service provider. And then lastly is the processor speed. So with the hosting service provider, we had sort of just standard, no big deal types of CPUs. And now with Azure, at least on the D series VMs that we're using for SQL Server, we have these CPUs that are 60% faster than normal kind of standard CPUs are. So we're getting much better value with Azure, and we're paying less per compute resource, even though overall we're paying more because we're now consuming more. All right, so just kind of one other thing I would point out here is that this pricing does take into account the discount that we got by going through a LAR and agreeing to pay for a certain amount of Azure upfront. So it really wasn't that much money. I think the first threshold is like $2,000 a year or something like that. So you commit to spending $2,000 a year, and you get a big discount on Azure as long as you pay that amount up front. So we will easily consume more than $2,000 per year in Azure, so we committed to that. We got our discount, and that helps adjust the cost from the list price that I showed earlier in the presentation to the price that we're seeing here. So in the end, Azure actually ended up being less expensive for us in terms of all of the resources that we need in order to be able to operate our environment, which I was surprised by. I really thought that Azure would be more expensive than our hosting service provider. And in terms of the value we're getting, it's actually much better than what we had with our service provider. Any questions on costs? No? Okay. And again, this will vary. You'll have to talk to your LAR. It might be different in Europe. I don't know. Depends on what you're trying to use. But and I didn't obviously do a comparison between Azure and on-prem because we don't have an on-prem environment. I don't have any sort of cost basis to compare that to. But at least versus a hoster, this was a better approach for us in terms of costs. There were some other reasons, though, for us to move to Azure. So one is the scalability. With our hosting service provider, we had 2 hosts, and we were constantly juggling like where we would create a new VM. We'd have to move one VM from one server to another in order to create enough space. And it was really just very tedious, right? And we didn't even have a management interface in order to manage our host VMs there, our host Hyper-V servers there. So if we had to move a server from one to the other, we would literally have to ask the hosting service provider to copy our VHD from one host to the other for us, and then we create a new VM on the other side. It was ridiculous. So it was really tedious in order for us to do scalability there. They didn't have a management interface for us. They do now. At the time that we first signed up with them, they didn't really have one. Now they're using OpenStack. So there is an interface if you buy a certain package with them. but just in general, it's really tedious to deal with scalability there. With Azure, when I want to scale, I just change the scale unit of a given virtual machine from like an A2 to an A3 in a drop-down. Click Save, and it upgrades my VM to that new compute size, right? So very easy to scale in terms of like moving a given VM from one compute tier to another. And also adding a new virtual machine is trivial. I just go to the new button, click a virtual machine, boom, I've got a new virtual machine. It's very easy. In terms of data growth, the storage array that we had at our old hosting service provider was this 4-drive RAID 1 array, and it was 500 gigabytes, and that's all you got. And in order for us to get more space, they would have to completely tear down the array, add more drives to it, and build up a new array. And so in order to do that, they'd have to move all of our VHDs off of that array, rebuild the array, move our VHDs back onto the array, and that would just been a lot of downtime for us to incur while they did that. And so with Azure, it's a bottomless data center, right? We can keep adding storage as much as we want without having any downtime even. In terms of deployment, with our hosting service provider, it was old school. You're creating virtual machines through the Hyper-V VM wizard, pointing to a VHD file, pointing at an ISO file. It's funny how that was sort of cutting edge maybe like 4 years ago or something, but now that seems so old school when you can just go into Azure and based on any VM template provision a new VM, or even like sets of VMs if you want to deploy something like a SQL always on availability group. So much easier to do new deployments of things in Azure. In terms of the pricing model, the hoster offers basically 2 packages. You can either get their 2-host package or their 4-host package of a private cloud. That's it. And you get a certain set of hardware with that. With Azure, they have like maybe 30 or 40 different pricing tiers for VMs, and then you have all kinds of different configurations. You can get an A series or a D series or a G series, and it all just depends upon whether you want a lot of RAM or you want a lot of hard disk speed, you want a lot of CPU. You can sort of pick and choose exactly what you want. And so you've got a lot more flexibility in terms of what you're consuming as opposed to a hosting service provider. With the hoster, the services that they provide are really pretty limited. With Azure, there's a lot of services. Outside of just IaaS, there's all these services for things like the load balancer and the multi-factor authentication and Azure AD and on and on and on. There's so many services that are all built around Azure that a hosting service provider just doesn't have right now. And even a hosting service provider that's taking advantage of like Windows Azure Pack, for example, still the scope of services that they provide is really limited as compared to what you can get from Azure. With our hosting service provider, the internet speed was good, but not really great like you get with Azure. Azure data centers are just sitting like literally right on the backbone of the internet. I wanted to actually measure the speed between the hoster and Azure, but I didn't actually get around to it. But we'll just take that for granted. And then automation, there's really limited opportunities for any kind of automation around hosters. With Azure, you've got Azure Automation as a service inside of Azure, and you've got PowerShell. There's a PowerShell module that you can use for managing Azure. And so there's a lot more flexibility and opportunity to automate things around Azure, which is going to be really important for us as we're spinning up new dev and test environments and bringing those back down and deploying our build to like our staging server and then our production servers and so on. And that automation is going to be key to us. And then lastly is the administration. So with the hoster, all the administration was DIY. You're inside of the Hyper-V admin console, and you're doing everything kind of manually. With Azure, it's at least managed to some degree. You're getting your VMs backed up on a regular basis, and they've got monitoring built into Azure, so you can set up endpoint testing and probes, and that sort of thing is all sort of just built right into Azure, so you don't have to do that sort of thing completely on your own. So those are some of the other factors on why we decided to go with Azure as opposed to our hosting service provider. And I think when you look at the combination of the cost savings that we had, along with all these other factors, the choice was really clear why we should go to Azure as opposed to using our hosting service provider. So in conclusion, Azure can cost less. You'll have to look at your exact requirements, talk to your LAR, and figure out whether or not it actually does cost less for you. And oftentimes, I imagine you'll be comparing an on-premise deployment to Azure as opposed to, in our situation, we were comparing a hoster to Azure. So you'll have to just kind of do the comparison on it. But I think that based upon what I've seen, Azure pricing can actually be pretty competitive. And not only that, but the pricing for Azure is just continuously going down, right? I've never seen Azure prices go up yet. They're always going down because they're in a death spiral with Amazon right now, and 2C is going to get to the lowest price, right? And Azure provides a lot of services like backups and monitoring and things like that that can reduce your operational costs. So that's something to factor in. And then moving Service Manager to Azure is actually really relatively easy. Now that we know how to do it and we've done it once and sort of learned the things that I've shared with you here today, I think we could probably go back and do this Azure migration in probably like 4 hours or less instead of the 36 hours it took us to do the first time. So anyway, so hopefully you can learn from the lessons that we learned, and if you do decide to move Service Manager to Azure, it's relatively simple to do. You just have to have that VPN connection back to your on-premise environment, if that's what you need. And then moving to Azure can improve your performance for the same cost. So as we saw earlier, although we're spending a little bit more per month right now, we're actually getting a large bump in the resources that are being applied to our environment and seeing an improved performance for that same cost. So this is actually a really successful project. We're excited about being a Microsoft partner running Service Manager inside of Azure, and we'll actually be producing a white paper that will basically just take all of this information and produce a kind of reference architecture for how to operate Service Manager in Azure. And we'll also be doing another webinar on this topic on, I believe it's February 18th, so next week sometime. And if you want to tune into that, we'll talk a little bit more in detail there about how to operate the Cireson portal within the context of Azure. And probably the one thing that I would point out here is that if you do decide to put your management servers up into Azure, it's important to take into account the potential additional network latency that you have, right? So if you have your main console users that are sitting in your corporate office, and they're used to connecting to a server that's very local to them and has a fast connection, and you move that Service Manager management server up into Azure, and that introduces additional latency, that's something that you might want to measure before you move to Azure, is what would that additional latency be. And one of the things that you can do to deal with that additional latency is to use something like the Cireson portal, where instead of sending serialized .NET objects over the wire, you're just sending JSON data over the wire. So that really reduces the amount of data that's being sent on the wire and can improve performance when you're using a remote Service Manager management server like that. All right, so that's it. Thank you guys very much for coming out. I'll be available up here for a few questions. I do have to go to the airport here in just a few minutes, though. So if you have any questions for me while I'm here at the NIC conference, please come talk to me now, because I won't be here in 20 minutes. So stop by and ask me any questions that you have. And it was great to see you all again here at NIC, and hope to be back again next year. Thank you.